Cysec provides world-leading, high-performance cybersecurity tools to ensure robustness, confidentiality, and integrity for the space internet networks and critical infrastructures. Before launching Cysec, Patrick played an active part in the world's first exit in quantum technologies. Patrick has specialized in creating business value from security for governments, banks, the industrial sector, and telco, using his deep experience in security, especially in technologies relating to quantum computing and cryptography. Patrick earned an undergraduate degree in engineering at the University of Applied Sciences and a master in project management at the Geneva School of Business Administration.
Cysec is providing high-performance cybersecurity tools to ensure robustness and integrity for the space internet networks. And I am really excited to your presentation. I just want to tell everyone that you can post the questions in a chat, and then we will take the questions after the presentation. Patrick, the floor is yours.
Okay, thank you. You can see my presentation?
Yes.
Perfect. Okay, nice to meet you. Thank you for the invitation. I am Patrick Winkler, CEO and co-founder of Cysec. We founded Cysec in 2018. We are based in Luxembourg, Switzerland, France, and Italy. We are more of 100 clients, and we have 3 products: an operating system, a VPN, and a lib. Cysec is the largest cybersecurity event for the space. It's based in Paris, and yes, this year we did in Paris and in Washington with the different support from the French Space Agency, ESA, White House, and some other institution. I am I'm hardware engineer, and I started to work in the quantum field from beginning 2000 with another venture, a spin-off of University of Geneva, ID Quantique. And after, yes, founded Cysec and developed another approach of the quantum with Cysec. Just maybe to discuss what do we talk about today is that for practical quantum resilient security for space, and we talk about a market of €1 trillion in 2030, the space one. We talk about a market of around €100 billion for the communication. This is in 2031, and we talk about of 50 million of terminal connected to this space in 2026. And just to mention, right now, today, we have 10 million terminal connected to the space. 5 to 6 are from geo connection, and 4 to 5 from the LEO. And just last week, Starlink did the announcement that they have 4 million new, 4 million subscription. They use the Starlink infrastructure. And we see there that acceleration, important acceleration for the adoption of the space. I think we will launch every year 10,000 new satellites, but our vision, our idea is that right now this building block is ready, and we need to improve it and use it, develop some use case, some business around this space infrastructure. From my point of view, is like a space internet. It's a new evolution of the internet, the expansion of the internet to address 50% of the population. They don't have access right now to the internet, and to address all different devices, or they don't have access to the internet, and to develop new business around that. Just the evolution of this kind of industry have some weakness, and the security is one of that. We have several examples with the hack of the Russian hacker on the Viasat infrastructure, the hacker terminal. And or we can see right now a lot of evolution of the hacking of this infrastructure. We see that in Ukraine and some other country. They have some limitation right now for the latency, the data restriction, and they have some limitation about the interface and the connection. Idea is that it's right, like in the beginning 2000 with the internet. We are in the beginning of the space internet right now. Just maybe for the fun, if you have time, you have this great guy, is James Babur. He was student of University of Oxford. He did he take $300 of equipment and they hack. They take just they take just information with this antenna, and they take the information to share it via satellite. And right now it's not encrypted. And you see that they have the YouTube video. You can see that they explain exactly the demonstration they did easily with $300 equipment and with a software for analyze the data. And we see right now there are no encryption right now, no security, this kind of infrastructure. Our vision is that all will be connected. We have right now 4 kind of different infrastructure. We have the cloud and the on-prem infrastructure. Is the traditional internet, is IT, information technology, and the evolution with the space with the new space LEO constellation. Is a IT approach. It's not anymore operation technology. And in the second step, we will have a edge device. Right now, it's operation technology infrastructure will be IT, and that's really the evolution. We have everything. It will be one infrastructure, IT infrastructure, and we will use tools we have right now in the cloud. For example, Kubernetes, in order for orchestrate all this kind of infrastructure. And these kind of tools are developed for have every time the connection and to have a important throughput. And for that, as mentioned before, we need to improve the quality of this kind of space or satellite network in order to have the capacity to transform everything in IT. And we have 3 products of Cysec. We do the operating system in order to develop the confidential computing at zero trust infrastructure in the different deployment, encryptor with the accelerator, and we have a library for encrypt the connection via ground station and satellite. And in order to be practical, I will address different use case. We have 2 different use case. The use case from the user of the space infrastructure, and I have some other use case for the player to develop the space infrastructure. From the user, one of the largest vertical they use the space connection is the maritime one, from different reasons. Okay, and we know that they have a lot of pressure right now in this maritime sector with the pressure they have on the supply chain, with the different activity they can have or risk they have around some geography. In this case, we have the setting is a very complicated one. You have the boat. They will have a connection GEO in some kind because you cannot have access to LEO satellite. In some part of the world, you will have the LEO connection because they're very cheaper as the GEO one. And when you are in the port, you will use 5G connection because the LEO and GEO is already expensive. It's still expensive as the 5G. Okay. And that means you need to have the encryptor. They can use the same encryptor for the different connection, okay? Not to have every connection a VPN. That means it will be very complicated to manage. We need to have a solution that can be used in the different topology, okay? And this infrastructure is provided by security provider. That means the final user will take this infrastructure from infrastructure as service provider or platform as service provider. And that's very important in this kind of topology to be zero trust. The idea is that the infrastructure provider, they will give you the connection GEO, LEO, 5G, to give you the server, the antenna installed of the in the boat, need to be a zero trust. In zero trust, it means that we need to have isolation between the hardware managed and the application, and the hardware and some part of software managed by the infrastructure provider, and the infrastructure managed by the data managed by the final user. And in this case, it's very important for the key management in the zero trust, from my point of view, is that the final user to manage the key. And the key need to be quantum resilient right now. And the idea that in this kind of topology, the final user need to have a HSM, hardware security model, that is certified, and all HSM around the market are already quantum resilient. That means they have the different algorithm validated by the NIST. Maybe someone, because the difference between the BSI and the NIST, BSI the choice some other algorithm, is real to have this agility. That's the philosophy of the quantum post-quantum, is real to have this kind of different algorithm post-quantum, and to change it in function of the topology, in function of the regulator, in function of the geography, okay? And to run this kind of algorithm inside of the HSM, and to deploy a post-quantum PKI, they will deploy the key in the different place in the boot. For example, because it will be a mesh mode topology. And very important, it's something is not very used right now, is to have a TPM inside of the server, inside of the boot, in order to store the first key. And can be generated by a QNG, but idea is that to have this kind of topology, okay, zero trust, isolation, key management managed by the final user, to be quantum resilient, like with a post-quantum, and run inside of HSM, and to have a key rate of every day a new key. And maybe if you want, the headquartered with the HSM can have a backup of the key of the HSM with in a recovery center connected with an encryptor, and to use maybe quantum key description system in order to exchange the key or to this backup. And the encryption and the authentication has to be already quantum resilient, to be IES 226.28 is already quantum resilient, but right now the standard is IES 256 in GSM mode with the encryption and authentication. That's really the setting we provide, and I think is the best setting for this kind of industry. Oh, sorry. Second use case is the mobility. It's one of the new user, I think, after the maritime one, the second user of the space internet. And in this case, we have a static is not easy to manage, because more of all kind of it is hardware are the hardware from operation technology. Idea is that it's hardware. There are no this setting you can find typically in the cloud or on-prem with that, for example, with a TPN. And it's very important to integrate a TPN. And it's very important to not trust the hardware of the drone. For example, you cannot buy a drone from China in US. That means behind that, we cannot trust the hardware. This is just a simple example. And to generate isolation from the hardware, from the software point of view, is extremely important. And to add, for the hardware point of view, some external equipment like the TPN is very important. The same thing will be, we have a connection terrestrial and space. we need to have encrypted available for do this kind of connection. And maybe something we had new for the key management is the post-quantum multi-party computation. You will have a lot of drone that will work together in the same time, and each one they will have a small key, quantum resilient, in order to communicate all together. That's the idea, to have a topology that if you will lose the drone, it's very easy to lose a drone. We will not lose the security of the infrastructure. And to have the access to have, as we do right now in the field of cryptocurrency, to use the multi-party computation, but to use this kind of a multi-party computation quantum resilient, and to integrate post-quantum algorithm directly in this kind of infrastructure. And something new is that there are some we have some standard right now, like SDLS standard, but it's more used in the space industry, more for the infrastructure, not for the user. But I think this kind of standard is already developed for this kind of connection. The last use case for the user of the space is real. The final topology is that you can see real the complexity we will have in the future. We have a edge device connected via terrestrial or space connection. They need to be in a zero trust mode, provided by different provider. We have headquartered. They will be in the different place. They are already connected with the fiber, and we have a recovery center or some others building connected to the headquarters via satellite or fiber. And in this case, you will have a extremely important several user of or provider of this kind of technology you cannot manage, and it's really extremely important that you will manage alone your key management. You have everything's isolate with confidential computing. With you can use the trust zone of the ARM, or you can use other kind of technology or in the zero trust, and to have your certified hardware for the key management, and integrate quantum resilient solution like multi-party computation, post-quantum, or PKI post-quantum, or finally to have a QKD for the fiber side. And my last use case is the use case of the player to develop the space infrastructure. And in this case, they have this new standard. Is the standard SDLS provided by the CCSDS. Okay, and in this kind of standard, it's very strange, is that they develop a lot of the standard in order to encrypt the connection between the ground station and the satellite to satellite. Okay, for manage the satellite, for manage the telemetry, to manage the command of and control of the satellite. In this kind of standard, there are no key management inside. They are just encryption and authentication. Use IES 256 with in GCM mode with the authentication, and there are no key management. Okay, in the standard. That means we need to implement it. That was something we offer at Cysec, the key management side, and the key management is over this link, can be optical or RF. Right now, the RF is more from the ground station to the satellite. They have some small optical connection provided this kind of topology. The difficulty of the methodology difficulty you have at this optical connection. From my point of view, for the moment, it's only RF, but between satellite to satellite is optical one. And we know that Starlink have already several satellites, around 86,000 they have already with optical connection. And right now in the satellite is operation technology. You can find more FPGA, and there are no TPN, and that's one big problem, because if you want to launch your satellite, you need to provide your satellite to, for example, SpaceX, or you can provide your satellite to your ESA or Ariane 6, but you lose the control of your satellite. Person they can integrate a malware very easy, and without a TPN, you cannot have a temper detection. You are not temper resilient. And finally, the idea is that you will manage all these kind of topologies: satellite, ground station to satellite, satellite to satellite, GEO, LEO, MEO, and maybe to the drone with this standard. And the idea in this kind of standard, the idea to implement HSM in order to manage the key, post-quantum PKI in order to share the key, to have right now, the idea is that they have just one key, initial key, to use this initial key in the satellite, but you really to have accurate in the satellite, and maybe between satellite to satellite, because the optical part is very easy to do, and you can implement a QKD between satellite to satellite, and to integrate a QKD in the ground station for the backup for the key management. And this is the standard for improve the quality of the infrastructure, space infrastructure, but the standard not integrate the key management for the idea to have to be quantum resilient, and something we need to integrate right now, and it's one of the goal of Cysec. It's all from my side.
Thank you so much. And it was really nice to see the architectures and the case studies. We had some questions in the chat. I noted it because there was afterwards quite a lot, and it was from Nigel, and he was curious, why would hackers want to hack satellites? And his follow-up was, how could I prove that a hacker is hacking satellites to the law enforcement?
Yeah, okay. Right now we know that the major risk we have for the active satellite is between the ground station and the satellite. That's very important to protect links. 90% of the hack is around this link. Okay. We know that, for example, they have several hacking on the satellite. We have it's reported by media that one satellite was hacked by some Russian satellite some year ago. We had the example with some information from India. They have 4 satellites hacked by the Chinese in last year. And we see real some activity around that, because the importance of this satellite for Earth observation or communication dramatically increase with the different pressure we have right now in the geopolitical world. And now for with the integration, the encryption, idea that when you use a IS, for example, in GCR mode, you have the CTR mode too. We have a counter inside of the encryptor in order to count the data frame, and with that we have more and more information in order to analyze the kind of hack and to protect and to detect some activity.
Thank you. And then we have one more question. Mahima, from Mahima, he would like to get a bit more explanation on why authentication was mentioned as a resistant to quantum attacks.
No, the idea is that authentication and encryption is okay. Authentication is for, in order to have a, idea that the security is a chain and all rings need to be robust the same size. And we will not integrate just a post-quantum key with encryptor. we need to authenticate the packet too. The idea is that we need to have a same level of quality overall for your infrastructure.
And I also have a question to you about, because you shared all those examples, but what I understand is that in the end, you want systems that could get like the keys from different technologies, right? Could be provided by QKD, could be provided by a random key generator, but in the end, you're really interested in this post-quantum security. Is that a form for you to have this like a mixed architectures?
Yeah, it is that you know, you have a different technology. This kind of technology need to be developed in order to have two kind of user. The final user, they have only access the key, and the provider or to integrate this kind of technology to the final user. That's extremely important. And after, in function of your topology, you can implement this kind of solution. For example, in the fiber one with the QKD, for the optical one, if it's more with the post-quantum one, and finally, to manage the key directly in the device to be connected with the satellite, you need to have a place to store the key and a place to check if there are no changement in your device with a TPN, and for example, a remote attestation.
Okay. We got more questions. So now it's from Edward. Does incorporating post-quantum cryptography has an impact on hardware power capacity?
Yeah, absolutely. That's clear. But you know, for example, the HSM used right now, you can generate a lot of key per second, and finally it's used only we don't use all kind of key. For idea is that right now the hardware we have can be quantum resilient already. We provide some algorithm already inside, and yes, we need to work. That's one kind of initiative right now for have the capacity to support this kind of algorithm in the hardware. That's something is a work in progress for support this kind of mathematical power inside of the hardware. Yes.
And Nigel wanted to follow up on his questions and then ask what he should focus on when he's doing investigation to strengthen the evidence of satellite and drone hacking.
But you know, there's some activity right now that it's really in the beginning. For example, in this space, we started to have some SOC to analyze it, and I think if you are just as James did, to have just an antenna and to you take all information inside and you have a Wireshark in order to analyze the frame, and you can see that they have some reordering where you can see that they have some integration on new frame, and it's the same, they are not connected to the message. We see that they have some activity around this link, and after some activity they have some innovation point of view right now in this kind of field is to use all kinds of information, you know, with some AI algorithm in order to detect of some kind of evolution of your infrastructure from the hacking point of view.
Thank you. We have a lot of questions, and I would like to suggest that maybe, Patrick, if you could take them in the chat, and then we could, since everyone booked some amount of time for today's event. But
maybe one thing is, if just one thing I can share here, you can see you have my email address. Happy, so you can send me email if you want with some question, and you know, we are passionate by the quantum side and happy to discuss with you.
Yes, so thank you. If you could answer the questions in
the chat too. Yes. Yeah.
then we could move to our second talk of today. Thank you everyone for all the questions. It's great that we have such a nice discussions.